Good morning. I am Dr. M. Fatima. Today I am taking differentiator circuit using operational amplifier. The differentiator is the circuit whose output waveform is the differentiation of the input waveform. The differentiation can be constructed from the basic inverting amplifier. Here the input resistor is replaced by a capacitor which was present in integrator. This is the circuit diagram of the differentiator. Vin is the input voltage. C is the capacitor which is connected here. The input resistance is replaced by this capacitor which was present in the integrator. A resistor is connected in the feedback. The input is given on the negative terminal of the op-amp and the positive terminal of this op-amp is grounded. So the capacitor current. Now let us do the calculation for the output voltage of differentiator. Here you can see that this is the circuit diagram of the differentiator. Here I have taken C1 as the capacitor which is connected at the input and RF is the resistance which is connected in the feedback. I'm considering I1 is the current flowing through this capacitor and it is divided into IF and IB. Here this is IB current is flowing. Now the current I1 is divided due to this parallel path. So current I1 is equal to IF plus IB. So I'm taking I1 is equal to IF plus IB. IB is the current flowing through this operational amplifier. But since the input resistance of operational amplifier is infinite for an ideal op-amp, so IB is taken equal to 0. So therefore, the I1 becomes approximately equal to IF by putting IB equal to 0. This is negligible. So I1 is equal to IF and I1 is the current flowing through this capacitor C1 and IF is the current flowing through this resistance R1. Now do the calculation for I1 and IF. So I1 is the current flowing through this capacitor and on this terminal of the capacitor, Vin is connected and on this terminal of the capacitor, V2 is present. So I can write the value for the capacitor, the current flowing through the capacitor, which is equal to I1 is equal to C1 differentiation of the voltages are Vin and V2 and current flowing in this direction. So I can take Vin minus V2. But we know that V1 is equal to V2 and since V1 is equal to 0, therefore V2 is also equal to 0. So this is due to virtual ground. Now I can put V2 equal to 0 here. Therefore, I1 is equal to C1 d by dt Vin. So now this is the current I1. Let it be the equation number 1. Now do the calculation for IF. So IF is the current flowing through the resistance R1. How much it is the current on this terminal of the resistance RF, here V2 is present and on this terminal of RF, V0 is present. So the current flowing through this resistance IR is equal to V2 minus V0 divided by RF. So IF equal to V2 minus V0 upon RF. Now we know that V2 equal to 0, therefore IF is equal to minus V0 upon RF. Now we know that the I1 is equal to IF, so put the value of I1 and IF here in this equation. Since we know I1 is equal to IF, now put the values here, I1 and IF, and do the calculation. Now put the value of I1 and IF. So I can write here C1 dV in by dt equal to minus of V naught upon RF. So output voltage is equal to how much? Minus RF C1 differentiation of input voltage with respect to time. So this is the output voltage for the differentiation. For the differentiator, this is equal to the minus RF C1 differentiation of input voltage with respect to time. So I can write output voltage is proportional to the differentiation of input voltage with respect to time. So the differentiator circuit differentiates the input voltage. This RF C1 is the proportionality constant. So now you can see here, if the input is the cosine wave, if cosine wave is given to the differentiator, so if we differentiate the cos, how much it is? This is equal to sine wave. So the differentiator circuit will also give the sine wave. Output will be sine wave. Similarly, if the ramp signal is given, that is t is given, and if we do the differentiation of the t, the output will be 1. So if ramp signal is given to the differentiator, the output will be unit step function. So similarly, if the triangular wave is given to the differentiator, the output will be square wave. That is, ramp signal will be converted into the unit step function, depends on the value of the or the direction of the ramp signal. So this completes this lecture. Thank you.